Okay, today we're going to talk about probabilities of what are called disjoint and then overlapping events. So it says to find the probability of A or B, you must consider what outcomes, if any, are in the intersection of A and B. Two events are overlapping if they have one or more outcomes in common. Okay, so for example, this, right, would be the union of A and B. But then we have to take into consideration that this little part here, we've counted this twice. If I just say, well, it's all the probability of A plus the probability of B. Well, this section, I counted that 2 times. So what I need to do is figure out, well, what is that little section? That's the probability of A and B, and subtract that out. So then there's what are called mutually exclusive events, which have no outcomes in common. So like the probability of rolling a 1 or a 2. A 1 or a 2, there's no way that those have overlapping outcomes, so you just add them together. So, for example, let's see. Here, by the way, this should be an and. So let's just do one. I think it makes the most sense if I just work one out. So it says a card is randomly selected from a standard deck of 52 cards. Find the probability of selecting a 10 or a face card. Okay, well, in our deck of 52, 4 of them are 10s. So it's 4 over 52. And then also in our deck, it says or a face card. So a face card would be a jack, a queen, or a king. There's 3 for every suit and 4 suits. So that's 12 over 52. Not times, plus. Okay? So we can add these together and we get 16 over 52. Is there any way that you can be a 10 and a face card? No. So this is my final answer. I'm going to simplify it by dividing everything by 4. That gives me 4 over 13. And that is my final answer. Okay, on the next part, it says find the probability of selecting a face card or a spade. So in our deck, again, there's 12 out of 52 face cards. And then or being a spade. Well, there's 13 spades. But here's the problem. Are there face cards that are also a spade? Yeah, there's 3, right? The jack, queen, king of spades. So minus 3 out of 52. So 12 and 13 is 25. Minus 3 would be 22 out of 52, which would become 11, not that, out of 26. And that's our answer. Okay, find the probability of selecting an ace or an 8. So there's 4 aces in our deck of cards, and there's 4 8s in our deck of cards. So 4 plus 4 would be 8 over 52. Those are both divisible by 4, and we get 2 over 13. Okay, and then this last one, find the probability of selecting a 10. So that's 4 out of 52. Or a diamond. And how many diamonds are there? 13 out of 52. Okay, well, can you be a 10 and a diamond? Yes, there's 1 10 of diamonds, so we have to take that one out. So 4 plus 13 is 17, minus 1 would be 16 over 52, which we could simplify. They're both divisible by 4 into 4 over 13. Okay, out of 200 students in the senior class, 113 are either varsity athletes or on the honor roll. There are 74 seniors who are varsity athletes and 51 seniors who are on the honor roll. What's the probability that a randomly selected senior is both, right, a varsity senior and on the honor roll? So we know that the probability of event A, okay, we'll say A is being on athletics, is 74 out of 200. And then the probability of being on the honor roll, we'll call that event B, is 51 out of 200. Okay, and so what I'm looking for is, well, what's the probability of being on the honor roll and being in athletics? That's what's missing, right? So what other number do I have? Well, I know that it says 113 are either varsity or on the honor roll, right? So the probability of A or B is A plus B minus A and B. So 113 out of 200 is A plus B minus A or B. So 74 plus 51 gives me 125, correct? Yes. So 113 equals 125 minus some number. So 125 minus 12, right, would give me that. So that means that 12 people must be on both. So if it asks you what's the probability, that's 12 out of 200, which would be 6%.